Students, welcome to lab. Today we're going to deal with cis-trans isomerism, and that deals with maleic and fumaric acid. All right, so as we see, so remembering a couple of things as we introduce the experiment. We're going to be doing the experiment. I'll be doing the experiment. You're going to be watching, but you'll be recording the data, observations, all of those types of things, doing any calculations, making decisions about when melting points occur and that type of thing. All right. Then after that's done, you're going to write a lab report, as we've seen before, and this is going to be a typical lab report. I have a few more details, remind you of those at the end of the lab video. And then you're going to submit your lab report as one PDF file through the lab e-learning site. You're going to upload that, and this one particularly as video experiment 9. All right, so let's talk about cis and trans isomers, or cis-trans isomerism. So remembering that cis and trans, the idea of cis is that there are two things on the same side. So we saw this back in about chapter 4 when we looked at chlorine and bromine. This was the cis-trans isomer of it coming through here, both on the same side, as opposed to the trans, where again we had chlorine and bromine and they're sort of on the opposite side. So this was a thick wedge, this is the broken hash going opposite ways. All right, so cis and trans, so we've seen this before, and it's just the orientation about a bond that doesn't move of two particular groups. In this case, it's chlorine and bromine. It could easily be two chlorines. It could be cis and trans, or two methyl groups. All right, so we've seen that before. So how does that work today? Well, again, what we're going to do is break down maleic anhydride into maleic acid using water. We're going to make the cis isomer initially. So again, the idea of cis is that we have these two carboxylic acid groups that are on the same side of this double bond. Previously we saw a ring, and that also you couldn't rotate a ring bond. Same way you can't rotate a double bond. All right, and so we have this, so it's cis. Initially with water, water is just going to react with maleic anhydride to get here. And then further, if we add a little bit of HCl, what can happen is that we can protonate this double bond, make it a little bit labile, let it react, and then we'll end up with the trans configuration. The trans is a little bit more stable because we get these two groups, again the carboxylic acid groups, further from one another. All right, so it makes it more energetically stable and lower in energy to have this. All right, so the cis conformation of this particular acid and the trans. Because they're cis and trans, we give them two different names because they're ultimately two different molecules because of the cis and trans in a lot of ways, and they have different melting points, and some of the other physical properties are different, although their molecular weight and some of those properties would be the same. All right, so we see that. One of the things that we're going to end up with after we do the experiment is the IR spectrum. And this is for maleic acid. You're also going to get it for fumaric acid, and these are the ones shown in the lab manual, but also we're going to gather some in the laboratory too. All right, so a couple of things. As you interpret this, one of the things that you want to do is use our 5-zone method. All right, so to look at zone 1 and then 2, 3, 4, and 5. So use that to help drive your observation of this to see where these peaks absorb. Notice down here that these are given, and we'll try to give you those into the experimental one as well to see where the peaks are. So this is 3068. I'm sorry, this one's 3068, and then 2900, 2924, and it moves on from there. So you want to report this in the lab report. You want to talk about this. You can show these and sort of identify where these are and make connections to particular groups. All right, so is it a CH2 group? Is it a carbon double bonded oxygen? Whatever it would be, you want to identify those peaks. One of the ways that you can do this, and this is just a sample data table, and a good way to do it sort of by table is to list the characteristic peak that you're observing, all right, what the frequency is, like say the textbook frequency, and then what you observe. All right, and so you could do something like this for maleic and fumaric acid. Now again, notice this is just a sample data table. It's not from maleic acid, but nonetheless it gives you a sense of how you could take the data here and put it more into table form for your report. All right, so a great way to actually do that. All right, so as we go through the experiment, one of the things I want you to do is to be thinking about some observations, thinking about the procedure, noticing various things along the way, and making sure that you're recording data. We're going to try to make that obvious with the camera so that you can get values for mass or melting point, whatever it would be. All right, and so we'll do that. And so let's get ready to do the experiment. For this first part, we need to weigh out 10 grams approximately of maleic anhydride and add it to 15 milliliters of distilled water. has been heated just to boil. So before we go out the maleic anhydride, we're going to get the water heating. I measured out 15 milliliters of distilled water. So we have that working, and now we want to set up a beaker, 15 milliliter beaker, on an iron ring with our Bunsen burner. This guy. So go ahead and go it this way. This about here. Going to make sure that we have about as much room as we need. Alright, so I have this. So we put 15 milliliters of water in there. Of course, turn on our Bunsen burner. Alright, and we got that set, and we'll go lay out the maleic anhydride while this heats up. So we need about approximately 10 grams of our maleic anhydride. All right, so we want to make sure we weigh that out. So first I will zero out the balance just to get it to 0, and then I'm going to use a piece of this glassine paper, so some weigh paper. Put that on there. Notice it weighs a little bit, so I will tare it. So again, the idea of tearing means that you're correcting for the weight of the piece of paper. All right, occasionally it'll jump up that digit, so we're just going to tear it again, get about 1 gram, and then I'll start adding the maleic anhydride. All right, so we need approximately 10 grams. So again, we have about, you want to write this down, we have about 10 points. We'll go with 10.54. Notice we have some bubbles. You can probably see the steams coming off up here. So I would say that that water is just boiling. So I'm going to add this in. Go ahead and turn the water off. And grab a glass rod. Put it in my beaker here. Drawer me. And stir the beaker. So again, notice that it initially melts and it all goes, yeah, looks like it's all completely melted there. And so it's heating up. There's still a little bit of boiling that's going on. It's still a little bit hot while that's happening. So once it's completely dissolved, what we want to do is put it in pour it in a beaker of water. So I just grabbed a large beaker of water and put some of this in there. So it looks like I got maybe just a little too much for this. So I'm just going to put it in like this, and we're going to let that cool for a little bit. We're setting up for the next part, the Buchner funnel, but as it's cooling, I thought you might be interested to see that we have some white crystals that are forming, crystals of maleic acid that are forming. All right, so this is still not quite finished. I'm going to stick it back in the beaker, let it cool a little bit more. We're going to set up the Buchner funnel apparatus for filtration, and I'll be back in a second. At this stage, I think we've finished making all of the maleic acid that we're going to. So if you'll notice, there's a lot of solid, and there's not a lot of liquid, as you'll see. So now we're going to set up a Buchner funnel, and just let you know, I've got a piece of filter paper in there, and we're going to wet it with some water, and we're going to filter it. One little change is that the procedure talked about weighing the filter paper and air drying it. What I'm going to do is, since I'm going to oven dry it, I'm going to change that slightly, and I've weighed the watch glass, and so the watch glass weighs 52.74 grams, and so I'll eventually put the solid right on here to dry. All right, so just note that, and I'll show you a little bit more of that in just a second. So again, let's go ahead and hook up our Buchner funnel to here. Turn that on, and again, a little bit of water just to wet the filter paper so that it sticks well to this. Yeah, you got that. Make sure it's good suction. things are getting better there. All right, so I'm going to add a little bit of the liquid. This will be the mother liquid, so to speak, and a little bit of the water that I had to make it stick. We'll change it just slightly. It'll just add slightly more liquid. That'll be okay. So again, getting this out. Okay, so I think I've gotten a lot of that out, just a little bit, as you can see, little bits here and there sticking to the beaker. At some point you have to stop and move on. So we're going to let this air pull through to dry this maleic acid up just a bit, and then we'll get ready to take it back to dry in an oven. So finished the filtration. We'll move this to the side, and again we have our watch glass here, weighs 52.74 grams, and we're going to scrape our maleic acid on here, and we're going to dry it in an oven. You see just a little bit. It looks like I dropped just a little bit there. We'll get that on. All right. And so we'll scrape this off, and then we'll take this back to our oven. So we're in the back of the lab. Notice we have an oven. It's set to about 100 degrees. We also have our maleic acid. So open this up. Notice there are several things in here, so we'll make sure we set ours on the top shelf there. So there's our maleic acid, and we'll let that go. And we'll start the heating, and then we'll probably let that go for about a half an hour or so. I'll give you the time in a second. The filtered solution, which we also call the mother liquor, came from the original solution where we reacted the maleic and hydride in water, and then we filtered off the solid maleic acid, and then we ended up with this liquid. All right, so this liquid is the mother liquor. It's also referred to as the filtered solution. All right, so to this we need to add 12.5 milliliters of hydrochloric acid. So we'll add that. So notice it had a little bit of color change that went on. So that we added there, and then we want to add it to a round bottom that we then heat up. All right, so let's go ahead and get this set up. So we add it into here. So we're going to leave, we've got a little room there left, and we're going to put a heating mantle under it. We'll get started for now. Alright, so one of the things that we also want to do is in a reflux solution, which is what we're going to do, we're going to heat this other liquor up, heat it up to allow it with the added HCl. The added HCl will help the maleic, which is in the cis conformation, it'll help that double bond break temporarily, form the lower energy that is more stable trans conformation and form. And so the acids, we're going to heat that up, give some energy to let that happen. So we need to use one of these vertical condensers, and they're sort of what they call the small bore and the large bore. So we want to use the large bore, and we're going to put it into this vertical position. We're going to run some water through it. So let's go ahead and set that up as well. So we'll need another clamp here. We're going to extend this out just a little bit. So this will fit right in there nicely. So tighten that up. And I need to bring that back just a little bit to let it sit in there tight. But again, this is sort of by itself would be unstable, so that's why we want to have a second clamp for that. I have a clamp here, and there's no plastic or anything right around here because this is going to get hot once we add the heating mantle. And then we want to add water to this, so we have our water tubes. So I'll tell you what I'm going to do is turn this on just a little bit. Wet both sides of this. This helps just getting this on. So I'm going to add these ones. Alright, so the bottom one is where we always add the water. And so that's going to allow the water then to fill and then to come out the top one. And then the top one will flow into the sink. All right, so allow this to circulate up and allow the water to work out. All right, so I'm going to get a heating mantle and we'll be back and we'll get this started heating. All right, so we've just about got this set up. Again, we've got our tubes already set, so we're going to probably keep those away from the heating mantle. I'm going to drop this down just a little bit and then raise it back up so we have a nice tight fit here. That's underneath. Again, the manual talks about using high heat, so we want to go all the way to the brightness of the bulb. And so we're going to heat this up. We also, at this stage, make sure our tubes are connected. Hopefully they're all going to stay on. And we just need a little trickle of water that's going to run through this. So we've turned the heat down here. I've also lowered the heating mantle just a second. And you can notice that it's heating. So you might notice some condensation that's occurring here. And then you actually see a condensation ring that's occurring here. All right, and that's the reflux that's occurring that we talked about. So the reflux is really heating the solvent up with these water tubes with our water flowing through there, coming up, cools it down and then allows the solvent to return. All right, so this basically allows us to heat the solution fairly high without heating away the solvent. So we're able to sort of have this continual mix of allowing this to occur. All right, so what that permits us to do then is to heat up the reactants to fairly high temperature. You might remember back to the Percy Julian video, and in there they talk about adding a little bit of heat gives the bonds energy, allows them to break. And that's really what's happening here with the maleic acid in the cis conformation. We've added the HCl. The HCl helps that double bond break temporarily. The molecule switches into the fumaric acid and then reforms. And it does that, in this case, by we're giving a heat in acid to have that occur. And again, we're keeping it down. And so there's usually a condensation ring that occurs. Generally, you want to keep the condensation ring in the lower half. All right, so if it starts getting too high, you can turn the heat down. Because if it starts getting too high, then we'll have the solvent that will be coming out. Now, this idea of reflux, heating up, refluxing, condensing, and going this cyclic turn is probably something that you know. Probably in the kitchen, if you've ever cooked. If you cooked rice, typically you heat the rice up and then you cover it with a lid, or maybe put aluminum foil over it, so you're not letting the water out. If you're cooking some sort of vegetables, oftentimes you'll put a lid on the pan with just a little hole so the pressure doesn't build up, but basically allowing that water to condense so you heat up the vegetables. All right, so that's similar to what's happening here in reflux, is that we're getting a high temperature. You notice some popping, and that's again because the solution's heating up. But ultimately the water and the HCl and the other things that are in here, even the products, they're not actually heating up and going away. All right, so we're going to let this go for the 10 to 15 minutes that it talks about and be back to finish it up. So we're just over 10 minutes of heating, just barely over 10 minutes, maybe about 11. And so I'm going to stop heating here. So I think we've gotten in, so you can notice a lot of the white solid, and that is the fumaric acid that is formed. And again, we're going to let it just cool just a little bit. And again, a lot of the fumaric formed, the white crystals, as it was actually heating. So we're going to wait just a little bit to make sure that all the tack forms and crystallizes here. And then we're going to collect it and then recrystallize it, that is, more purify it. All right, so we'll be back in just a second to show that. All right, so we finished heating this, and I feel that the more fumaric acid is actually solidifying here. So what we can do is go ahead and separate these. So I can come off. Oh, there we go. Push that off to the side, and of course then what I want to do is bring in my filtration apparatus. I got a piece of filter paper. Once again, I'm not going to weigh the filter paper. I'm going to actually use a watch glass since we're going to heat it in the oven. And I'm going to heat this We're going to filter this, so set this up. Alright, so one of the things I did last time as well is to get just a little bit of water, get it, and heat this guy. Yeah, so make sure this sticks there, so that's looking good. And so now we're going to separate the crystals of fumaric acid from the solution. You start to see some of the suction that's occurring, so that's coming off. And so then we also want to make sure we're getting the crystals and some of those. And so I will endeavor to scrape these guys off. And so again, a good thing to do is always use sort of a curved one of these. That's a good help for getting crystals out of a round bottom. Many of you have worked with this. All right, and so let's go ahead and get a few more of these crystals. And that'll help with the filtration. So the next step is to take our crystals of fumaric acid, put them in a beaker, and weigh them to see how much we're going to need for recrystallization. So we'll be back with that in just a second. So we're over here in the hood. We have our fumaric acid, 2.7 grams of that. We need to recrystallize it, and it says about 12 milliliters of hot water for every gram of this, since that comes out to 32.4 milliliters. So what we can do is grab our hot mitt and a graduated cylinder, and we'll measure out the 32.4 of the hot boiling water. Alright, so that was actually just a tad much. Well, that's about right. And so we're going to add our 32.4 of water to that, and we're going to stir it. And the goal, remember, with recrystallization is to get all of the solid to dissolve. All right, so we're going to get that to dissolve, so we might need a little bit more, so we'll put that back on. But we want to keep our solution hot, so we'll stir it up a little bit to get this guy to dissolve. So you can see some of it has gone in, but not everything, so we still need a little bit more heat. We might need just a little bit more water. We want to use the least amount of water or solvent, in this case, any solvent, but in this case water, to get this dissolved. That'll end up giving us the best results with the lowest amount, because then we'll be able to recover the most solid once it crystallizes. So it looks like we still have some in there. Alright, so we're starting to get fairly clear. I don't see a ton of solid as I'm starting to stir this up. Oh yeah. So as I stir it, you can tell that it's mostly staying translucent, right? So it does have a little tannish color to it, but there's no more solid there. And that means we have gotten the recrystallization. We can shut this off, and I'm going to let this cool at room temperature. Here's the balance, and we have our maleic acid from the original part. I will tear the balance or zero it, and we'll find out that our original mass of just the watch glass was 52.74 grams. Now the mass with the maleic acid is about 62.58, so almost about 10 grams. All right, but remember we want to get this to constant mass, so we've dried this already for an hour. Notice the water, the air bubbles that are formed because of the water going away. We're going to put this back in for 10 minutes and see then once it cools if we get a mass that's very similar. So we're here to filter the fumaric acid. Again, it's cooled for about an hour, so I left it cooled for that long. And so again, just want to vacuum filter it. Again, piece of filter paper, just a touch of water to make sure the filter paper sticks down. This is connected, so we'll turn this on. And we're going to filter the fumaric acid. That to the side. So again, we have our fumaric acid. Again, instead of using weighed filter paper, I'm going to use a weighed watch glass. Again, 128.48 grams is the watch glass weight. And I'm going to scrape out the fumaric acid on this and then give it a dry in the oven. All right, so scraping out just the last couple of things. And we're going to take this and get it in the oven. So we've zeroed the balance. This is the second of the two products of the fumaric acid. Remember, our watch glass weight was 128.48. And this one about 2 grams or so, a little less, 130.18. And remember, this was a heating that was initially for this one about 10 minutes. All right, so we only went about 10 minutes for this first heating, and it was pretty dry already, I thought, so I thought we'd get away with that. So we'll see how it is. We'll put this back in for 10 more minutes and see if we get something close to this 130.18. Okay, you can see this is for the second product. This is the fumaric acid. Notice the original, after the first heating was 130.18, this is 130.17, or 18, it is exactly. So if we go with 131.7 or 18, those both are within 0.05, and so we'll finally call this 130.18. So you can see that this weighing is 62.36, and that is significantly different than the first one, which was 62.57. So we need to put this back in the oven. We need to get a constant weight. So after the second 10-minute heating, again we see that the maleic acid is 62.18. Again, we're looking for a difference of less than 0.05. And our previous one was 62.36, so this is clearly, even if we go with 62.19, it's more than a 0.05 difference, so back in the heating chamber. We're back to the maleic acid. Notice the previous heating is 62.18, this one's 62.04, so yet we're still not within the 0.05, so back into the oven for 10 more minutes. The maleic acid, 61.94, so we're getting close, but we're about 0.1 away, so we still need to heat it just a little bit more. Folks, this last heating was only 5 minutes, and see we're at 61.91, and so that is within 0.05, and so we're going to call this one done. All right, so I will post a sheet of all the heatings and their times, but the first heating was an hour, then we had 1, 2, 3, 4 10-minute heatings and then a 5-minute heating. So now we're going to go on to get the melting point and the IR. Alright folks, we're going to get the melting point of maleic acid. Remember, its melting point's about 130 or so. And because I knew that we were going to have a fairly pure sample, I already started the temperature at 110. I'm going to ramp it up at about 10 degrees a minute, so about every 6 seconds we'll go up a degree. And then I'll have it stop up at about 150 or whenever it melts, really. So I'm going to have one camera. It's going to be looking, we'll move it. It's going to be looking at the temperature. And then I'll have a second camera, and we'll go down the eyesight. And I'm going to allow you to watch sort of at the same time the melting and also the temperature change that's going to occur. So we have the temperature preheated to about 110 degrees. And we're going to slip in the maleic acid. And I'm going to start the butt. And so it's going to ramp up at about 10 degrees a minute, so about every 6 seconds the temperature will increase 1 degree, and so we're just going to let it ramp up. Again, the temperature is in the range of about 137 to 140. Right, so we want to watch this and watch it melt. Now we've done the experiment, we want to talk about the lab report. So this is some of the details that I've listed in the most up-to-date syllabus schedule. That's posted in the lecture e-learning site, and it has sort of the full schedule from here to the end of the semester, and it gives you a few details. At the very end of that, where we detail the lab reports. So again, much like the last one, you have one of two ways. First way, you can type the whole thing. So as you're watching it, you're on your laptop, on your iPad, whatever, you're typing up the title, the purpose, the procedure, all of the things that you would need in a lab report. All right, so you see those, and you're typing that in Word or Pages. Maybe use a Google Doc. Maybe it's something else. So you're typing that up, and it's just one completed report. Of course, you want to include the IR spectra and those types of things, but have that together. The second way would be to use your laboratory notebook, the same one you've used all semester, to sort of handwrite your name and the title, purpose, procedure, all of that, observations, bring that all together, do any calculations, and then type up the conclusion as normal, and then put that into one document. All right, and so again, using something like TurboScan or Genius Scan or the Notes app, whatever it would be, to actually bring those the handwritten parts and the type conclusion together into one particular group. And again, no matter what you do, again, you want to, if you have the Word or Pages or Google, you want to convert that into a PDF document. All right, and so that's for the final lab report. So again, good job uploading things so far. Just make sure they're PDF files. And again, continue to work hard, and we'll get through this semester.